system, and we'll discuss the different techniques to representing a data, representing a numerical data, a text data, or several other data, other informations. Okay. So look for the efficient implementation. Uh, so let me start. Okay, so number system. So what is the purpose of number systems? As we discussed, you might be familiar of some number system earlier also. So number system are used to quantify the magnitude of something. Magnitude of something. It is used to quantify the magnitude of something. One way of quantifying the magnitude of something is by using the relative way or proportional way. For example, we often quantify the things like that. So suppose we can quantify the height of the students. The height of the students A is the or A is the taller than the student B. Height of the student is more than B or smaller than B, like that. Right. So this way of quantifying is called as the analog quantification or proportional quantification. So with respect to is a reference value, we are actually comparing whether it is how far it is from the given reference value, given principal value. Right? The other way of quantifying is the number is by using the numerical way or by using the representing this quantification in terms of digits. Right. So there are many number systems to quantify for the digital quantification. There are too many number systems are present. So first, uh, we are our most familiar number system is the decimal system, decimal number system, right? And we discuss several other number system with respect to the we are studying the several other number system with respect to this number system, the primary, the our main number system, that is decimal number system. This is our most familiar number system. Okay, and we discuss the other number system which is most convenient to represent in a computer system, right? So decimal system is not very convenient to represent something in a computer, but if we go for the other kind of number system, it is more convenient to represent the quantity of something, the magnitude of something in this way, right? So the second important number system is the binary system, binary number system. The third one is octa number system or octal system, octa number system. Hexadecimal number system, hexadecimal, and so on, right? So how we classify these number system? So as we most our if we started with our most familiar number system, that is decimal number system. So how we representing? Okay. So, although there are many number systems are present, but the most frequently used number system in the applications of the digital computers are the binary system, octal system, decimal system, as we are most familiar with the decimal system, and hexadecimal number system. Right? So how we quantify? We start with the our most familiar number system, that is decimal number system. So we differentiate the number system with respect to the base, what is called base radix of a number system, right? Base and radix in number system, it representing base or radix representing the number of different symbols, number of different symbols or figures used to represent any quantity, used to represent any quantity in a number system, any quantity, right? Just like our family system, that is number, that is radix, the decimal number system, we use these symbols to represent any quantity. We use only these set of symbols, any combination of these set of symbols, right? So it is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we can represent any quantity by using these different symbols, by using these different figures, right? So by using these quantity, we can represent any number systems, right? So as we can say, we can represent 512, so 512. So using one of these symbols, we can represent any quantity, right? So this symbols, if we write this subscript, it is representing the base of this number system. So if we use this subscript, by default, we usually believe that the number system what we are using is a decimal. But although this symbols representing that this quantity 5112 is right now it is represented in decimal number system. So 10 is representing what? Base of this system. So base of the base of or radix of the decimal number system is 10. Radix or base of decimal system is 10. Why 10? Because we have 10 different symbols to represent any quantity, right? So this is represented, if you represent anything like that, this is representing that this 5112 is represented in decimal number system, right? So now we discuss the other systems in which the base could be different, just like a binary system or octa system or hexadecimal system or any radix system in which the base could be other than 10, right? Since we are most familiar with the number system, which is in decimal number system, we always, you know, we always study other number system with respect to the decimal number system. So how it is converted any quantity which is represented in decimal number system to other number system or other number system to decimal number system, right? So see here, uh, if we talk about the binary system, our digital computer using this system only, but still we are also study, octa system and hexa system. Why we are studying octa and hexa also, although we almost all digital computers are using the binary number system only. So we'll discuss these all those questions, all those terms. Okay, the binary number system, the base is equal to what? We have only two distinct symbols to represent any quantity. Means base is equal to or radix is equal to 2, right? So the symbols are only 0 or 1. So we have only two symbols to represent any quantity. Right. So now the question is how we representing 512, which is in decimal system, in binary. How we represent any quantity which is in decimal system in binary system. Right. So this is called the mapping techniques. means how we map a quantity which is represented in one system into a different base system. Means we are converting the base. Okay. So this is the binary system. Now similarly, we have the third system called as octa system. In octa system, we have 8 different symbols. So base is equal to 8 means we use 0, 1, 2, 3, 4, 5, 6 and 7 to represent any quantity. In octa system, the base is equal to 8. We have only 8 different symbols to represent any quantity. So we have 0, 1, 2, 3, 4, 5, 6, 7 to represent any quantity. So this is called the octa system. Now the fourth one called as hexadecimal system. In hexadecimal system, the base of the hexadecimal system, the radix of the hexadecimal system is 16. We have the 16 different figures to represent any quantity. So what are the 16 different figures? The first 10 different figure is same as the decimal system, that is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now we have another symbol which represent actually the equivalent to 10. So this is the value of this symbol is 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Now we have some other additional symbol which is representing 10, but although this is very one symbol, only one symbol, right? So just like how we're representing 10 in decimal system by using two symbols, right? 1 and 0, we are representing 10 in decimal system. But in this, we can represent it 10 by using just one figure, by using just one symbol, and that is A. Right? Now, the next symbol we use is B. We use C, we use D, we use E, and we use F. The corresponding value is, since it is representing 9, this A is representing, A itself is representing 10, B itself is representing 11, 12, 13, 14 and 15s, right? So 0 to 15, how many different symbols are there? 16 different symbols. So this is called as hexadecimal system. Now we look for the interconversion. Is any query?
Yes, sir. In hexadecimal system, you have written till F, and there are total 17 numbers.
Total 17 number. No,
Yeah, sir, you have written 17 numbers in hexadecimal system.
1, 2, 3, this is up to 10, 11, 12, 13, 14, 15 and 16. Okay.
No, sir, it is correct. I have made a mistake. Sorry, sir.
Is it correct?
Yes, sir. I had made a mistake.
Yes,
Sir,
sir, it
it
is
is
correct.
correct. Sir, please repeat once.
See here to here, how many symbols are there? 10 symbol, 0 to 9, 10 symbol. And how many additional symbols are there? 6. 1, 2, 3, 4, 5, 6. Right? So 10 plus 6, how many total symbols are there? 16 symbols. Right? So we have total 16 symbols. And the value of each symbol is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it is 10, 11, 12, 13, 14 and 15. So F representing 15. F itself representing 15. E itself representing 14. right? D itself representing 13, C itself representing 12, B itself representing 11, A itself representing 10, like that. Right? And of course, the rest of the symbols are same as the decimal symbols, right? So, in order to represent any quantity, now we use the combination of these symbols, right? 0 to 9 and A to F. How we use this symbol to represent any quantity, we'll discuss, right? Uh, if we discuss the interconversion. Now the thing is, the important thing is, since we are familiar with the decimal system, we can represent any quantity by using the decimal system, right? Just like I have represented 512, right? 512. So the 512 can be represented in decimal system in this way, and this is representing that this subscript is representing that right now this quantity is represented in decimal number system, right? So if you write the same quantity, same figure, not same quantity, 5112, and if I write instead of this, if I write here 8, now this 5112 is representing some different quantity, because this right now it is represented in which decimal, which number system? The octal number system, right? The octal number system, how many symbols we can use? 0 to 7. So here also we use the 0 to 7, 5, 1, 2. So this is an octa number system, right? But it is representing some different quantity if we claim that this is an octa system. If we claim that this is a decimal system, it is representing this quantity. If it is claimed that it is represented in octa system, it is representing some different quantity, right? So now we can convert this to the equivalent decimal system in order to know what is the value of this system, what is the value of this quantity. Right? So whenever we say the value of any quantity means what? We are talking about indirectly its decimal equivalent. Right? So this is 5112. And same thing, if we claim the same figure 5112, 512, right? And if we claim this is represented in hexadecimal system, so we are representing, the subscript, we are usually using the subscript 16, this base, this is representing a base, right? So, and we can claim that this could represent a different quantity if it is represented, if it is interpreted as a decimal, as a hexadecimal number system, right? And this quantity cannot be claimed that represented in what is called the binary system. Why? Because in binary system, what kind of symbol we can use? Only 0 or 1. But here we use 5 also, 1 also, and 2 also, right? 1 is allowed, but 5 and 2 is not allowed in binary system. So we cannot claim that this 5, 1, 2 is in binary system. This claim is wrong, right? But this claim is correct. We can represent some different quantity. It can be interpreted as a hexadecimal system. It can be interpreted as a octal system, and it can, of course, it can be represented, it can be interpreted as a decimal system, right? Similarly, if we have a quantity like 1a b 2e, so this quantity cannot be claimed that this quantity is in decimal system or this quantity in octa system, right? This quantity is definitely in hexadecimal system, because the figure A, B, and E is not used in any other system. Okay, these symbols are always used in hexadecimal system. So now we discuss their interconversion. So if a quantity is represented, if a quantity is represented in one radix system, how we can convert in different radix system. So in number system, we usually study the mapping of one radix system to another radix system. Mapping of one radix system or one base system to another radix system. means some quantity is represented, and right now it is represented, suppose in radix system R1, in R1 radix system, this is base, right? And now we would like to convert the same quantity in radix R2, right? The same quantity we are like to convert in radix R2, just like in our previous example 512. Initially it is represented in, suppose, octa system. Now we'd like to convert the same quantity into hexadecimal system or binary system or some any other system, right? A very natural way of converting any number system to any other number system by taking an intermediate way, by converting it to radix 10 system, and from radix 10 to radix R system, right? Means there is always way of convert any quantity which is represented as one radix system, R1 system, to the decimal system, right? Once you got the decimal equivalent of any quantity, now we can convert any quantity which is represented in decimal system into some different radix system, that is R2 system, right? So we always have, for all radix case, for all the cases, not for the not restricted to only for the decimal or binary or hexa or any other system, any radix system, right? It could be other than hexa, other than octa, other than binary. Suppose the radix 5 system. Suppose we are representing radix 5 system, although radix 5 is not very much used in digital computer, but we can imagine a number system which have the base 5. So base 5 means we have what kind of symbol it is using: 0, 1, 2, 3, and 4. It is radix 5 system. Right. So we always have a methodology to convert any radix system to the equivalent decimal system, and from decimal system to any other radix system. So this is the ultimate way of converting, mapping one radix system to another radix system, right? But some of the time, for the few cases, what we have a direct mapping from radix one radix system to another radix system. Directly we can map. For some cases, not this is not possible in all cases. This is restricted to some cases. Restricted to some cases. Which case it is possible? Now I am comparing this R1. We like to convert from R1 to R2 radix system. Base R1 to base R2 or R2 to R1, right? If R1 and R2 is related in this way, right? Here I am writing R1 and R2 is related in this way. We are converting R1 to R2 or R2 to R1, right? So if it is related in this way, R1 is equal to R2 to the power k, where k is any positive integer, any non-negative integer, or any positive integer, we can say. K is any positive integer. If we have this relation, this means, suppose for example, we are talking about the binary system. What is the value of radix? 2. We are talking about the hexadecimal system. What is the value of the radix? 16, right? Can we represent this 2 and 16 in this way? Yes, we can represent the 16. We can represent the 16 as 2 to the power, that is R1 to the power 4, right? Similarly, if we have here in octa system, and here we have binary system, again we can represent this 8 as a 2 to the power 3, right? So if we have this relation in R1 and R2, then we have a direct mapping. We have a methodology to convert the R1, the quantity represented in R1 system to the equivalent quantity represented in the R2 system. If we have this relation, then only we have a direct mapping technique. Otherwise, we always have We always have what mapping technique? R1 is converted to the decimal system, and from decimal system, it is converted to the R2 system. Yes, if you have question, then you can ask. Any question? Okay, fine.
सर
Sir,
Yes.
कैन यू सर प्लीज एक्सप्लेन इट अगेन सर सर थोड़ा समझ में नहीं आया
Which one?
सर इन द कन्वर्जन पार्ट सर
yes,
Yes,
sir.
yes. I'm not discuss any conversion techniques, right? I'm just discussing what. Suppose we have a quantity which is represented. What quantity? Still, we are not disclosing them, right? Suppose we have a quantity which is represented in the radix R system, radix R1 system. So let's see, right? Now we'd like to convert the same quantity into means the into some other radix system, that is radix 2 system, R2 system, right? So for that we always have how we convert that, the methodology. Now we'll discuss, right? So how we converting the radix R1 to the decimal system and decimal to the radix R system, how we converting that we need to discuss, that we'll discuss, right? But we have a methodology, we always have a methodology to convert any radix system to radix 10 system, that is decimal system, and from decimal system to any other radix system. We have this methodology, the general methodology, right? But our interesting thing is we need to convert R1 to R2. For that, what we converted R1 to 10, then 10 to R2, right? But sometimes, for some cases, we have this a formula, an expression for this directly conversion from R1 to R2. But for which cases we have, this is not available for all cases. For which cases, if R1 and R2 means either R1 we are able to represent R1 in terms of R2 like that. R1 is equal to R2 to the power k, where k is some positive integer, or R2 can be represented as R1 to the power k. Either this one or this one. If it is possible, then we have a direct mapping techniques. We have a directly means if we wish to convert from any quantity which is represented in R1 to equivalent quantity represented in base R2, we can have direct expression, we can have direct transformation, we can have direct conversion, right? But if we are unable to represent this R1 and R2, we are unable to relate the R1 and R2 in this way, then we are unable to convert this quantity directly. What is the alternate way? We have a definite way to convert from R1 to 10 and 10 to R2. That's it. I'm just discussing till now. I'm just discussing these things. That's it. Right. Still, I am not discussing how we convert R1 to 10 or 10 to R2, and how we convert R1 to R2 directly if we have this kind of facility, if the R1 and R2 is related in this way. Till now we have not discussed, right? So any question till now? Is it clear now?
Yes, sir.
Okay, fine. Now first I'm converting I'm discussing from the radix R to decimal. Radix R to decimal. Radix R to decimal conversion. Radix R to decimal means radix R to radix 10. Radix 10. Radix R to radix 10 conversion. Suppose some quantities represented. So quantities we representing. Suppose the individual AI is representing the individual digits. The individual digits or individual figure, we can say. AI is representing individual figures, just like suppose the quantity is in 1, 36, right? Right now it is in, let's say, the base 9, although base 9 is uh, uh, not a very standard number system, but suppose right now we assume that this is in base 9. Now we like to convert this quantity. This is not actually 136 because this is not in decimal number system. Now we like to convert in decimal number system. We like to know the value of this if it is interpreted as the base 9 system. It can be interpreted as a base 9 system because the individual figure is not more than 9, not equal to 9 and not more than 9. So in the one thing we always observe that the value of individual digits, the individual figure in any radix system is strictly less than the base value. In binary system, what is the figure value? 0 and 1. What is the base? 2. Right? In decimal system, what the base? 10. And what is the individual value of individual figure? 0, 1, 2, 3 up to 9. Right? In decimal, in hexadecimal, what is the value of individual figure? 0 to 15. And what is the base value? 16. So this relation is always maintained in any radix system, any base system. Okay. So this is now we like to convert this. This is represented in radix R system. R is equal to 9 into binary into decimal system, right? So AI is what? AI is representing this individual figure, right? So this is I is equal to, we can say this is I is equal to 0, 1, 2, right? So AI is 6, 3 and 1 individual figures, right? So now the decimal equivalent of the quantity represented in radix R system each can be computed by using this formula, summation I, and of course I is equal to 0 to up to how many digits we have. I is equal to 1 to n, or 0 to n minus 1, we can say how many digits we have. Wi ai. And what is wi? Wi is called as the weight of figure ai. Weight of figure ai, or symbol ai, or digits ai, whatever, right? So why we say always figure or symbol? Because if it is decimal system, this figure is called as digits. If it is a binary system, the same is called as bits. Okay. So this is weight of figure ai, and now each of the symbols not have the same weight. It depends on their place value, right? For example, what is the range of this weight? We started with this as a 0, the weight value of this as r to the power, and what is the value of r? The base, right? R to the power 0. This is r to the power 1. This is r to the power 2, r to the power 2, like that.
एक्सक्यूज मी सर, ये R0 R1 और R2 वाला मेरे को concept समझ नहीं आया.
Not this is r0, not this, not r0, r to the power 0, r to the power 1, or this is the weight of this individual digits. In any system, the individual digits have their weight. So this system 6 have the weight. Since 6 is positioned as right hand side, rightmost side, right? So this is called as least significant digits, LSB, and this is called as most significant digits, or most significant bits, MSB, right? So what is the least significant bit digits here? Because this is not in binary system, that's why we are not saying bits here. Why it is less significant? Because it's the weight is smaller as compared to the other digits, right? Since it is positioned as a right hand side, rightmost side, right? Rightmost side. Since it is positioned as the rightmost side, weight of this one is r to the power, that is r is what? The radix of this system. Radix is right now 9. So this is 9 to the power 0. Weight of this one is 9 to the power 1. Weight of this one is 9 to the power 2. 0, 1, 2. This is the weight of this.
So what is LSB and LSD? Can you please explain once again?
LSB is the least significant bit. Bit is called in case of binary system. Since it is not a binary system, we can say the digits, least significant digits, and most significant digits. Why it is least significant? Because the corresponding weight value is smaller than as compared to the other. And why it is most significant? Because the corresponding weight value is larger than as compared to the others, right? Since whatever the value of r, this is r to the power 0, the weight of this one is 1, weight of this one is r, weight of this one is r square, weight of this, weight of, if we have one more quantity here, then weight of this one is r cube. So
RQ.
right, so what will happen? It will give this larger weight. If we increase, if we go in this side, the weight is larger. If we go in this side, the weight is smaller. Just like if you compare with a decimal number system, their place value 10, 100, 1000, like that place value. I hope you're familiar with that. 10,000, then 100, then sorry, 10, 100, then 1,000, then 10,000, like that. The place value is increasing, increasing, increasing. If you move in left hand side, and what is the smaller place value, smaller thing, the smaller weighted value, the digits or the figure located in rightmost side, right? So this is the weight in any radix system. We are not, this is not limited to only radix 9 or radix, in any radix system, radix r, the weight of this digits is r to the power 0, weight of next digit is r to the power 1, r to the power 2, r to the power 3, like that. So weight ranges from r to the power, r to the power 0 to r to the power n minus 1, where n is what? Number of digits we have. If it is non-fractional, if it is fractional, again it is different. So we'll discuss the fractional quantity. If you represent, like that 57.526. So in that case, the weight value is different. So we'll discuss the fractional quantity, but right now we are discussing the non-fractional quantity. So the weight value is ranges from r to the power 0 to r to the power n minus 1 with what is n? Number of digits or number of figures we have. Number of figures in this quantity. Number of figures in this particular quantity. It not the case that whenever 6 is present, the weight is 6 is always r to the power 0, right? It depends on the place of the 6. Right? Suppose we have 1, 1, 1, 2. Again, this is in this is represented in, suppose, in decimal system, right? In decimal system. What is the weight of 2? 10 to the power 0. What is the weight of this one? 10 to the power 1. What is the weight of this one? 10 to the power 2. Weight of this one? 10 to the power 3. Right? So it depends on the position of the individual figure. Okay. So now we are converting any quantity which is represented in radix r system to decimal system. So we have this formula, this mechanism, right? WIAI. Now we use the same quantity 136, and we assume that this quantity is in radix 9. Can we find the equivalent quantity in radix 10? It is very easy. How we find? Now we go by the individual digits, right? So if you started from the least significant digit, that is 6, right? So how we added? 6 is multiplied with their weight. 6 is multiplied with their weight. So what is the weight of this 6? 9 to the power 0, that is 1. So 1 into 6 plus, what is the next digit? 3. 3 must be multiplied with their weight. So what is the weight of 3? What is the weight of 3? 9 to the power 1, that is 1. That is 9. So 9 into 3 plus, what is the weight of this? 9 to the power 2, right? That is 81. So 81 into 1, right? And this expression will give you the equivalent decimal quantity. What is that? Yes, if you have question, you can reach.
Sir, what will it give?
Sorry?
Sir, this value, what will it give?
This value will give the same quantity in decimal number system,
Okay, sir.
right?
So means this is written in a decimal system.
This is
81
written in decimal system. This is not written in, originally this is written in base 9 system, some different system. Now if we converted here,
The
so
base
it
will
is
be
now it
changed,
is
now.
written in decimal system. So the value is what? 114, right?
The base will
Yes,
change
sir.
while changing from.
Sorry?
सर बेस चेंज करेगा सर 9 से जैसे कि 10 हो गया वो.
हाँ, base ही तो change हुआ ना. See,
Yes, sir.
9 is what? 9 is representing this
Decimal
quantity is
yes.
not, we are writing some quantity, right? 136. Now the thing
Yes, sir.
is, how we interpret this quantity? What is the value of this quantity? Whether it is 136 or something else. It depends on the representation. So now we like to know that, okay, so if nothing is mentioned, by default we believe that it is in decimal number system, right? But we like to know that this quantity is represented in which real number system. So now we mention here, this is just a representation. It is representing, it is indicating that this quantity is not a decimal quantity. It is represented in base 9 quantity, right? Now we like to know that what is the equivalent value in decimal system. What is the equivalent value in decimal system? That we like to know, right? So we have converted by using this way, by using the weighted sum. And if we compute the weighted sum, it will give you their decimal equivalent, right? So right now, these two things are representing the same quantity, only the representation is different. It is these things, 136 is equal to 114, but this is not as much as we cannot represent, we cannot write like that, because by default this is in decimal and this is also in decimal, right? So now we like to indicate their base. So this is in 9, now this is in 10, now this is fine, now this is fine. Okay, so we are representing same value in different representation, in different number system, right? So now suppose we take one more example so that the things will be clear. Suppose I am writing this value 1111.
Excuse me, sir.
Yes, tell me.
Sir, what is the difference between LSD and LSB?
LSD and LSB. Are you
Yes,
asking
sir.
the same? Okay, so nothing is different. LSB, B is representing bits and D is representing digits, right? So whenever it is in binary system, this system, so instead of this one, instead of saying LSB, we say LSB, bit, or here MSB bit, and if it is other than the binary system, we can say digits. We can say digits also here, but here also we can say digits, but we cannot say here as a bits. Digits means it could be 1, 2, 3, 4 up to 9, right? Bits means it could be 0 or 1 only. That's it. So nothing, nothing to deal with. Don't worry about the what is B and D. It is same thing. Only the representation is different. If it is binary system, we usually call individual digits as a bits, right? If it is decimal system or other than binary system, it could be the octa system or the other system. We usually say the individual figure as a digits, right? Simple. In our natural convention, the individual figures of decimal system we say as a digits. But in binary system, the same thing is called as bits. So that's the difference of the LSB and LSD. That's it. Okay. See here.
एक्सक्यूज मी सर
Yes.
सर जैसे 136 था ना पहले वाले क्वेश्चन में,
One three
सर
six.
अगर यस सर, तो सर अगर हम 136 से पहले जो भी कोई सी भी डिजिट जिसमें 9 आ रहा है उसको 136 से माइनस कर देंगे उस सारे सम को, तो सर वो भी तो आंसर देगा कि 10 पे कौन सा वो आना चाहिए।
नहीं समझा, क्या माइनस करेंगे?
और सर जैसे 19 माइनस कर देंगे, 09 माइनस कर देंगे और 29 माइनस, ऐसे ऐसे करते करते जिन सब डिजिट में 9 आ रहा है उसको 136 से माइनस कर देंगे, तो सर ये भी तो आंसर देगा ना कि 10 पे कितने आने चाहिए।
136 को 9 से माइनस कर रहे हैं, क्या कर रहे हैं?
नहीं नहीं सर, जैसे 136 से छोटी जितनी भी डिजिट पे 9 आ रहा है, जैसे 09 पे आ रहा है, 19 पे आ रहा है, तो इन सब का सम जैसे 1 2 3 4 ऐसे करके जितनी भी डिजिट पे 9 आ रहा है, अगर उस सब डिजिट्स को मतलब उन डिजिट्स का काउंट हम 136 से माइनस कर देंगे, तो सर वो भी तो आंसर करेगा ना कि 10 पे कितना आंसर आना चाहिए।
नहीं, कैसे करेंगे? सपोज 136 को कन्वर्ट करना है 10 में, कैसे करेंगे?
तो सर जैसे 091 हो गया, 19 टू
0 और
29
9 1, 0 और 9 1 हो गया। आई मीन
सर,
ये
जैसे मतलब काउंट काउंट हो
काउंट कर
गया
रहे हैं।
कि
ओके,
यस सर। तो सर अगर ऐसा सारी 9 डिजिट जिसमें जिस भी डिजिट में 9 आ रहा है जो 136 से
जिसमें भी
छोटी है,
डिजिट में 9 आ रहा है।
यस सर,
ओके,
क्योंकि तो सर वो ही आंसर आना चाहिए कि 10 वाले में भी तब।
नहीं, आप क्या करो, मेरे को एग्जैक्टली समझ, आप यू कैन से टेल मी एन एग्जांपल सो दैट आई कैन कनेक्ट यू। सो व्हाट यू क्लेमिंग दैट you are claiming some different methodology for converting this to decimal, right?
नहीं सर, सर जैसे ये था ना कि जैसे 9 में, जैसे 9 वाले सिस्टम में 9 नहीं आता है, उसमें 8 तक ही आता है।
हाँ हाँ, ठीक है। हाँ,
तो सर मतलब एक्स्ट्रा हो गया ये 10
ओके ओके,
10
उसको
वाले सिस्टम में 9
आई
एक्स्ट्रा
मीन
होता गया।
आप ये कहना चाह रहे हैं कि इसको 9 से सब्ट्रैक्ट कर दें या 9 ऐड कर दें, ऐसा कुछ?
नहीं सर, मतलब जैसे 10 वाले सिस्टम में 9 एक्स्ट्रा आ रहा है 136 तक,
हाँ
जितनी भी
हाँ,
9 की डिजिट है वो 9 वाले सिस्टम में कम होंगी और 10 वाले सिस्टम में 9
नहीं
वाली
वैसे
डिजिट
नहीं हो,
एक्स्ट्रा आ रहा है।
वैसे नहीं हो जाएगा इंडिविजुअल। आप इसमें मिल रहा है, मैच कर रहा है कि 14114 मिल रहा है वैसे?
जैसे वैसे तो मिल रहा है
कैसे बताओ ये?
सर, जैसे अ, पूरी डिजिट जो 136 से पहले आती है वो होती है 9 19 29 39 49 59 69
136 से जो पहली आती है वो होती है क्या?
9
9
9 19 29 39 49 59 69 79 89 और फिर 90 से लेके 99, फिर 109 190 एंड 129।
ओके।
सर तो इन
So
सब का
we are
सम,
you are considering only those digits which have 9,
यस सर,
only those quantity which have 9, right?
यस सर, उसको 136 से माइनस कर देंगे, तो सर वो
Okay.
आंसर
Oh,
हर केस
okay,
में
okay.
आएगा।
So, I think you are you are claiming the same thing as we have claimed here, indirectly, right?
यस सर,
So what is that? We are finding the place value, the weight value, and adding. So we discuss some more convenient way of transferring or some different way of expression, right? So once you familiar, we may able to find out some more efficient way. Okay, so don't worry about it. Now tell me this answer. Suppose this quantity is represented in binary system, radix 2 system. Now you like to know the answer in decimal system. So what is the answer?
15.
It is 15, right?
15.
Yes, sir.
So how it is 15? Again it is 1 into what? 2 to the power 0, right? 1 into 2 to the power 0 plus 1 into 2 to the power 1 plus 1 into 2 to the power 2 plus 1 into 2 to the power 3, right? So this is 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3. So all four digits, 1, 2, 3, 4, right? So this is 8 plus 4 plus 2 plus 1, right? So this is 15. Now, I'm claiming that suppose this is 0, 1, 0, 1, 0, 1, 1. Right now it is expressed in radix 2. Then what is the answer? In 10. In radix 10, what is the answer?
41.
41 or something else? What is this value?
83, sir.
83.
Sir, 43.
43.
43.
Yes, sir. Yes, sir. 43.
43.
So 43.
Sir,
So
43.
this value is what? 2 to the power 0, 1, 2, 3, 4, 5. 2 to the power 5, 32. This value is what? 2 to the power? 2 to the power
3.
3. 8. This value is what? 2 to the power
1.
1. 2. This value is 2 to the
2.
power 0, 1. Right? 32 plus 8, 40 plus 3, 43. Simple. Right? Now I'm claiming that this is not in binary system. This is in radix 5 system. Then what is the answer in radix 10? What is the answer in radix 10?